Hi everyone, my name is Daniel. I'm an assistant professor here, and I'm going to be doing this online module looking at data infrastructures and specifically data infrastructures for research and teaching. So my goal with this series of videos is not to teach you how to do data analysis, but actually I think we're going to work on a problem that can be much more confusing or much more difficult to get started on, which is how do you set up an infrastructure to do this? And a harder question, how do you set up an infrastructure for students to learn how to be able to do this? Um, a long time ago when I was an undergrad, I took a computer science course. I wasn't a computer science major, but I jumped into an upper division computer science course, and I quickly realized that the most difficult challenge wasn't necessarily learning the programming, but it was learning the infrastructure that all the other computer science students had learned, and I had no idea how to do. So I didn't understand the pipes that move things around for these people. I didn't understand how to shell into a server and basically work in the way that they worked. I think that's really emblematic of the way that infrastructure can be a huge barrier right at the beginning of projects, and getting set up just to start doing the work can be really difficult. This is for students, but also for researchers. So I do analysis in R as well as Python. Getting started in Python, and especially setting up the infrastructure, can be pretty daunting and pretty confusing. And a lot of times we have really good resources for learning how to program, but we don't have really good resources for learning how to set up an infrastructure and how to make decisions about an infrastructure. So that's what I'm going to be starting with right now. Where we're going is building an optimal infrastructure for you to do your research and for you to teach. So kind of right off the bat, what that means to me is that if we're setting up an infrastructure for research, I'm going to be thinking about things like literate programming. So the concept of literate programming says that I'm writing code for myself and for humans, and we'll talk about it a little bit more later. It also means that I'm writing reproducible code. So I want an infrastructure that lets me reproduce my research both for myself and for others. And when we're thinking about an optimal infrastructure for students, I'm really thinking about consistency. So how can I set everyone up with the same environment so that I'm teaching them how to actually do data analysis, and I'm not constantly troubleshooting which Python version they're on or which package they have installed. So that's where we're heading. A couple big concepts to get out of the way before we start. The concept of literate programming has been very influential in how we do data analysis in the academy, as well as recent advances in data analysis infrastructure. So literate programming is an idea by this guy, Donald Knuth. This is a really old paper, but it's actually a pretty simple idea, and the main point is right here. So let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to human beings what we want a computer to do. And this seems like a really simple point, but and the fact is that most people do not write literate code. We write codes for humans. If you look at the research on how people in the academy do data analysis, it's an absolute mess. And I pulled up an example of some code that I had written. This is very standard for how people type code when they're doing analysis, but this file's a mess. I have no idea going back. I wrote this months ago. What I was doing here, why I was making variables called temp. I have no idea why I was running these t-tests. I probably didn't do anything with them. I know I didn't do anything with them. Also, a lot of times that means that we end up with just all of these files. So if you've done any kind of this kind of work, you probably have folders that are messy like this. So my files are named all kinds of crazy alt and time machine, and they have dates and final and final final. And if I go to my graphs or my output, I have no idea what any of these things are anymore. And most importantly, I don't know what the most recent one is. So literate programming is about writing code that looks more like like this. So this is a notebook that we're going to look at. I'm going to give you access to, and there's a lot of human language in here, and then there's a little bit of code, and then there's a lot of human language saying this is what's going to happen, and then there's a code. So that's literate programming, and that's a principle that we're going to be working towards as we talk about infrastructure. The other big concept or goal that we have is reproducible research. You've definitely heard of this, and as far as how that works in the academy, it's very field specific. So I tend to publish in information science, digital media, communication type journals. I've never been asked for my code or my data when I've submitted a journal article. In the sciences, that's much more common, and the goal is for other scientists to actually be able to run your code and reproduce your research. What I think is more important in the communication field is that you can reproduce your research so that you can go back, run your entire analysis, and get the same results. So that means I always know what's current. I always know that I've done the exact same things, and I never get lost in my own code. All right, so what we're going to do in this quick series of videos is I'm next going to go over the infrastructure that I think is most useful for you, which is RStudio Cloud, and I'll talk about why I think that's most useful for you. And then in the third video, I'm going to specifically get into research and teaching, and I've created a series of examples that you'll have access to, and I'll step through those examples and we'll talk about how to set up a class, how to set up assignments, how to set up research, and how to build your own infrastructure.